in this example, you can see this is like the Toblerone. So there's my triangle. It's different. Toblerone's got an equilateral triangle on either side. But here, I've got right-angled triangles on either side. And the base, one could be forgiven for thinking that the base was the 14 by 8 rectangle, but it's not. Here is the tricky bit. The base of a triangular prism is the triangle. And once we've got that in our heads, we can imagine that this thing is sitting on its base. There's its little right angle, and it goes up and it makes another little right angle at the top. So the base and the face on top, base on the bottom, are the same shape, and therefore the height of the prism is going to be that. In fact, I'm going to call it a capital H because there's another problem coming up with triangles, and that is there is the little height, small h, of the individual triangle. So we're going to be dealing with two kinds of heights when it comes to rectangular prism. One is the height of the prism. That is going to be the distance between the two triangles. Okay, that's the best way to think of it. Picture it standing up and picture the distance between the two triangles. And then you have your perpendicular height inside the individual triangle, and you may have to use Pythagoras to get it. Here you don't, because with a right-angled triangle, remember that the base of the triangle, so the word base is going to be used twice as well, and the height of the triangle, as long as they are perpendicular to each other, it's okay. So there's my little b there. So let's put the word base here as well. We're going to have the base of the prism, and that is going to be the triangle. And then we're also going to have the little base of the triangle. So let's call this one big B, base of prism, and let's call base of triangle little b. And that will be the side that is perpendicular to the height. I'm going to use two methods again to find the surface area for this triangular prism. And in order to do the first one, I need to add a net diagram. So what hasn't been worked out here is the side DF and AC of the triangle. In order to do a net diagram, and in fact, in order to do my second method of using the formula, I'm going to need the perimeter of the triangle, and I'm going to need DF. So the first thing I'm going to do is a little pre-calculation, and I'm going to say DF squared, or I could say AC squared, equals, remember that will also be 8, and that will also be 6. So I'm using the other triangle, but I know that the measurements are identical to triangle ABC. DF squared is going to be 6 squared plus 8 squared. I'm finding the hypotenuse, so I'm doing an addition sum here. So DF squared is going to equal 36 plus 64. DF squared therefore equals 100. So therefore DF will equal 10 centimeters. And I'm putting my units back right at the end. Okay, so there's the 10. That's also 10. Now I want to attempt a net diagram. There's going to be 3 rectangles. It's going to be 6 and 8 and 10, but they all have the same. I'm going to use the word height very carefully, but what I mean is the distance from there, the C to F. So this measurement is the same for all of them. It's going to be the 14. So I'm transferring the labels from my 3D picture to my 2D net diagram. And then, of course, I know that this has to map onto the 10, and this has to map onto the 6. And these net diagrams only have 2 triangles for the top and the bottom, and then they have their 3 rectangles. So either way, I need the 10 from Pythagoras, but I'm going to be able to work with it in different ways depending on my method of choice. So method 1, I'm going to add up all of the different shapes. Method 1 is going to be 2 of my right-angled triangles plus rectangle A plus rectangle B plus rectangle C. And of course they're, in this case, all different, but I could have 2 of them the same. In fact, for a Toblerone, all 3 of them are the same, but I must never assume that they're all the same. So that is 2 of half little base times little height inside the triangle. And then these guys will all be length times breadth, but I can see them already. They've all got 14 as their length. Hey, so it's going to be 14 times 6, 14 times 8, and 14 times 10. That will give me 2, and I must be very careful now and just select what is the base and the height of my triangle. There's the base, and the height has to be perpendicular. Or I could go back and look at the 3D picture, and I can see there, it doesn't actually matter which way we do it, whether we say 6 is the base and 8 is the height. But the way that it stands here, it's just easier to talk about the 8 being the little base. So it's going to be 2 times a half times 8, and the perpendicular height was then the 6. I'll work that out in a moment. These guys, I'm already ready to put down my answers. So that's 84, that's 112, and that's 140. Okay, if I multiply all of these guys together, I get 48. And then I'm just going to add up those last 3, and I get 336, giving me a total of 384 square centimeters. Now let's have a look at method 2, where I use the formula. It's going to be 2 times the area of the base. And remember that we're going to call the base the triangle. Whenever it's a triangular prism, the base is always going to be the triangle. So it's going to be what we just worked out for the previous one. It's going to be a half times the 8 times the 6, okay, plus perimeter of the base, 8 plus 6 plus 10. Okay, perimeter base times the height of the prism. Right, that might be something we need to get our heads around again. And I said that it was the distance between the two triangles. So the height of the prism is that amount over there. If you stood it up on its triangle base, the height would be the distance between the two triangles. So that's going to be 14. Okay. So this will give me, again, the 48. And here I'm going to have, these give me 24 times 14, which is 336. And that still gives me 384 square centimeters.